So if you were absent today on Monday the 26th, we are starting chapter 2. It's on reasoning and logic. It's kind of going to be unlike any math you've encountered before. Lots of words, pretty light on the numbers. It's going to lead us into an introduction to writing proofs. If you've heard of geometry proofs, they're coming lightly this chapter. Also, I passed back the tests to those who had taken it, and we discussed the retake policy. So I want to discuss that with you as well. If you want to take a retake in here, to be eligible, the first thing you have to do is complete any missing work. Okay, so if you have missing in chapter 1 for 3 assignments, those need to get done satisfactorily first. Then you have to schedule a time to come in and make test corrections on your original test. You need to do that with me, either in an out time or before or after school. You have to schedule that time to come in, and we'll correct the mistakes on your initial test. The third thing is you must have had a pretty thorough note card, and if not, you're going to need to update it. Once these 3 things have been met, you'll be eligible to do a retake, and you need to schedule that with me before the 10th of October. So, again, complete any missing work that you have. Make corrections on your initial test. Make sure you have a very thorough note card. When all that has been okayed by me, then you schedule a new test date, and that has to be done before or after school. All right, so on to chapter 2. In 2.1, we're going to talk about patterns and inductive reasoning. So our first task is going to be to look at a sequence of numbers, find a pattern, be able to verbalize it. I won't make you write it down, but you should be able to say in your head, oh, I know what's happening with these numbers. And then conclude what the next 2 in the sequence will be. So I'm going to do this note over here first. When we have a sequence of numbers that are following a pattern, and those numbers are increasing from left to right, oftentimes but not always, the pattern that's consistent is the same number is being added to both consecutive terms to get the next one, or look for multiplication. When you get to higher levels of math, you might be looking for other things, like powers and that kind of thing. But in this introductory to patterns and reasoning, generally, if the numbers are increasing, there's going to either be some adding in the pattern or multiplication. So I'm going to look at this and I'm going to say, am I adding the same number? Well, that went up 6 and this did not go up 6, so no. Then am I multiplying by the same number? That would be 3 times 3, 9 times 3, 27 times 3. I've just identified or found the pattern that I'm multiplying by 3 to get to the next number. So I would take 81 and multiply it by 3 for 243. And you can use a calculator if you want. And then I take 243 and multiply it by 3 for 729. So our first task is just look at the numbers. Is there a pattern? If so, and I can identify it, fill in the blanks for the next 2. So in my next sequence of numbers, the numbers are going down and up. Actually, I have a mistake here. This should be a 2, and this should be a 1. Sorry about that. Anyway, it should be right on your packet. It's just wrong on my sheet. So the numbers are going down in value from 2 to 1, then to half, and then to a fourth. When this happens, generally we're looking for some subtraction that's happening consistently, or division. And I say generally, not all the time. All right? So when I look from left to right and I ask myself, am I subtracting something consistently? The answer would be no. am I dividing by something consistently? Well, let's check that out. If I go from 2 to 1, I would have had to have done 2 divided by 2. And then if I continue, then the next thing I'd have to do is 1 divided by 2. That does give me a half. And then I'd have to do a half and divide it by 2. And when I cut a half of a pizza into halves again, I get a fourth of the piece. So it looks like I am dividing by 2, or I could say multiplying by a half, right? So that would give me 1/8, and then 1/16. So this one, I mean, you can view that as dividing by 2, cutting it in half, or multiplying it by half. Any one of those are correct. So let's go to this next one and see if it's going to fit this, this, or neither. So I'm looking at the numbers. They're going up in value. So the first thing I'm going to do is see if there's a consistent number being added. And it looks like from here to here, it went up 3, then up 3 more, then up 3 more. So if I verbalize that pattern, I would say I found it. I'm adding 3 to get to the next number, so I'll continue to add 3 and to add 3. Sometimes we have 2 things going at once. For example, maybe there's a number as my first in the sequence, and I multiply it by 2 and add 1. And then I take that and multiply it by 2, get 6, and add 1. And then I take the next one, multiply it by 2, and add 1. That's still a logical pattern of numbers, but it's just involving this one and this one. Those are a little harder to find, and that's more for Algebra 2. But just so you know, you can have more than one pattern at a time. This next one is an interesting pattern. I want you to take a look at it. And I want you guys to stop, and in class I said, see if you can figure out what's happening from left to right. I don't appear to be adding the same thing, because this was up 0, then up 1, then up 1 again, but then up 2, then up 3. Like there's not really a consistent pattern for addition. The numbers are increasing in magnitude, so maybe I'm multiplying by the same number, but I'm not seeing that either, right? So I'm kind of stuck. Well, these are just things to look for. It doesn't mean they're always going to be one of those 4. Like I just said, you might have 2 of the 4. So now I'm thinking, well, how do I get from one to the next? And in class, I can usually get somebody to say, I know what the next one is going to be. I know it's going to be 21. And then I'll stop and I'll say, all right, how many do you think you know the next one? And usually that'll trigger it. Kids will see, well, okay, I'm adding these 2 to get to this one. And then 1 plus 2 is 3. And then 2 plus 3 is 5. And then 3 plus 5 is 8. So I'm adding the 2 in front of it. So it still falls under addition for growth, but I'm adding the 2 to get to the next one. So my next one up here would be 34. This is a really famous sequence in math. It's called the Fibonacci sequence. If you were to Google that, which we did in class, but I'm not going to in the video, you would see that there is so much out there. It's very famous for its implications with math, church versus math, religion versus math, nature. It appears a lot, and I talked about it in class, but for this video, I'm not going to do that. So the next thing is going to be called making a conjecture. A conjecture is based on patterns that you see. So for example, if I were to say, you know what, Sophie has been gone 5 Wednesdays in a row, I'd make a conjecture that she's going to be gone on the 6th Wednesday. Something's going on. It's a conclusion you draw based on patterns that you see. So when you're given these numerical conjectures, you have to start writing out samples so that you can see a pattern. So in class, I said, well, you need to know that product means to multiply, so we have a little vocabulary in there. It has to be an even number, so those are our 2, 4, 6, 8, 10, 12, those, and an odd number. So I asked kids in class, I'd say, give me an even number, and somebody maybe would say 4. And they'd say, now give me an odd, and somebody would say 7. And I said, well, the product's 28. Right now, I can't tell you anything. I just have one sample. So I went to about 5 kids in class, and I grabbed 5 pairs of even and odd numbers, and I multiplied them. So even, odd, multiply for 18. Even, odd, multiplies for 12. And then even, odd, multiplies for 50. And I asked the kids, is there anything you can tell me that's consistent with all these results? They are all, and almost everyone said, even. I did enough of them where I'm like, well, I can't really tell you much about them, but I do know that they are all even. So my conjecture would be the product of an even and an odd number is always even. So for the sum of 2 negative numbers, again, I did the same thing. I had to create some samples, look at the results, and see if I could see something that was consistent. So here's a negative number. Sum means add. Here's another negative number. Down 1, down 3 more, I'm down 4. So let's try -2 and then go down 5 more. Either, and I've been telling you guys to think of football, you're back 2 yards, get sacked back 5 more yards, or temperature, it's down 2 degrees and it drops 5. I'm down to 7. Let's do one more and then bail on that one. But I have another negative number and another negative. I'm down 10 yards, get pushed back 3 more. I'm down 13. What do I notice about all of these guys right here? And you could tell me they're all negative. That would be my conjecture, that the sum of 2 negative numbers is negative. Right? So making a conjecture with numbers, you got to have some samples, and then you look at the results and find something that they have in common. So last step is, well, what is a counterexample? So we need to define that. So I'm going to go up right there where it's highlighted. And again, you can we've had highlighters in class, and everything that's highlighted, I'd suggest you get on a note cutter. So a counterexample is 1. There might be an infinite, but you only need to find one. I'm just going to say thing, probably not the best word, but one thing. Could be a number or an animal, that's why I'm not saying number. We're going to work with numbers and figures because it's geometry, but a counterexample is one thing that proves the conjecture, so whatever somebody is conjecturing, false. So I'm going to go back to Sophie being gone 5 Wednesdays in a row, and I've observed that pattern, and I say, you know what? She's going to be gone. My conjecture is Sophie's gone every Wednesday. That's my conjecture. Based on the pattern I'm seeing, Sophie's gone every Wednesday. But then she shows up on Wednesday the 13th. Wednesday the 13th is a counterexample. Okay? So, one thing. So here's my conjecture. If 2 angles are supplementary, I need to know what that means from first chapter, which means they add up to 180. Then they are both obtuse, and remember obtuse means greater than 90, which means I need to find 2 angles that are supplementary. So I have to meet the if part. So I'm going to say, okay, I've got 2 angles that are supplementary that aren't both obtuse. That's called a counterexample. So here's 2 supplementary angles. In class I said, what's supplementary to 150? And they said 30. And I said, are they both obtuse? And the answer is no. I could have said a whole ton of different counterexamples for that one, because that's a really bad conjecture. But all you need is 1. So 150 and 30 degrees makes a counterexample. All curly-headed girls get A's in geometry, is my conjecture. But then I have a curly-headed girl get a D. That would be a counterexample. All right, so my next conjecture, this is what I see. I have seen many, many 4-sided figures in my life that are squares. So I make the conjecture and I state, you know what, guys? all four-sided figures are squares. Somebody could raise their hand and say, LaRude. And what they would do is be finding something that meets this part of the statement, a four-sided figure that is not a square. In class, rectangle was the most common one I heard. Trapezoid is usually a very common one I hear. But any one of those, and you only need one. So you need to find one thing that proves the conjecture false. And the minute you find that one thing, it's no longer a fact. Okay? So I'm going to challenge you to find a conjecture. Find a counterexample to this conjecture. What should I say? Should I keep it a math one or not? Let's do all I don't want to do that one. Let's say if I'm going to make it geometry. So I'm going to tell you my conjecture is that if an angle is acute, remember what that means, then it is, let's say, 35 degrees. If I said, again, to find a counterexample, you're looking for one thing, so you're looking for one acute angle that is not 35 degrees. So many options, 1 degree, 2 degrees, 4 degrees, 10 degrees, 11 degrees. Basically, my counterexample would be any other acute angle that's not 35 degrees. And you only need one, so I'm just going to say a 40-degree angle is my counterexample. All right? So we're done. The homework is worksheet 2.1, and I will see you